Alright, in this video we are going to look at graphing a line by determining its x-intercept and its y-intercept. The x-intercept and the y-intercept are points on a graph, so once we determine those 2 points we can plot them and draw in our line off of those 2 points. So the way we're going to go about doing this is exploiting a fact we know about x-intercepts and y-intercepts. When we have an x-intercept, that basically means the line is crossing the x-axis somewhere. Well, for something to be crossing the x-axis, that means the y-coordinate must be 0. One of the ways you can think of your y value is it tells you how far up you would go off the x-axis or how far down you would go off the x-axis. So if we're on the x-axis, that y-coordinate must be 0 because we haven't gone up or down off of the x-axis at all. Similarly, if we're talking about the y-intercept, now we're talking about where the line crosses the y-axis. Well, if it's going to be on the y-axis, the x value must be 0. Because the x value, we could think of it as telling us how far left or how far right we're going to count off of the y-axis. And so if we're on the y-axis, that means we haven't gone left or right at all, which means that if it's on the y-axis, the x value must be 0. So those are facts of an x-intercept and a y-intercept, regardless of the equation you're given, whether or not it's a line or some other curve. If it's going to touch the y-axis, the x value or the x-coordinate will be 0. If it's going to touch the x-axis, the y-coordinate must be 0. So then how we exploit this is we just take our equation and we plug in for the y, we're going to let it equal 0. So when I do that, that gives me an equation that only has one variable that I can now solve for. So, because 6 times 0, 0, our y is gone, so I have 5x equal to 15, and then to get x by itself, I would divide off the 5. That tells me that x equals 3, which tells me my x-intercept is going to be the order pair 3, 0. And I can plot that. We're going to do the same thing for the y-intercept, except this time we're going to let x equal to 0. So I substitute in a 0 where x was, and this time I still have a y. I'm going to solve for that y. So 5 times 0 is 0, so it goes away. That leaves me with a negative 6y equal to 15. Now I'm going to divide off my negative 6. That's going to give me y equals a negative 5/2. So I started with the 0 for x, and I got out a negative 5/2, which is 2 1/2. I like to leave things improper, but when you're graphing them, it's a little bit easier to see where you're going as a mixed number. So then when I plot that, I don't go left or right any, which is good because I'm supposed to be on the y-axis, but I'm going to go down 2 1/2 and put a point. Just get that in the middle as best I can there and draw that in. And there you go. That's how you plot using x and y intercepts. I do want to note something very important here, that I think sometimes we get into the weeds when we're working math problems and we lose track of what our objective is. So what I mean is, if you're asked to plot something using the x-intercept and you think you're finding an x-intercept and you go to plot that point and it's out here in the solar system somewhere, you've not found an x-intercept. So if you're looking for an x-intercept, when you plot it, it needs to land on the x-axis or something has gone wrong. Similarly with a y-intercept. If you're looking for a y-intercept, when you go to plot whatever coordinate you come up with, if it's off in outer space, you've not come up with a y-intercept. So you need to go track your error. Alright, go ahead and give some of these a try and see how you fare.